Okay, let me start. And summer is finished. Autumn is coming, and welcome to new season of Smart Scrap Talk. And today I am glad to welcome you to the webinar Artificial Intelligence and Computer Vision for Steelmaking. My name is Andrei Karavlin, and today I joined to Smart Scrap Talk Vladimir Bashkov from Warden Machinery. This will be a very practical session, minimum theory, maximum real-world case studies. Vladimir is a head of business growth at Warden Machinery. He has more than 8 years of experience in projects across steelmaking, mining, and heavy industry. The Warden team has implemented solutions at a steel mill in Europe, Asia, and Africa. They won international innovation awards and already worked with such industry leaders like Sandvik, Bosch, Total, Michelin, and others. Please feel free to post your questions in the chat during the presentation. Vladimir will answer at the end of his speech. And before the presentation, let me briefly tell a few words about Smart Scrap. We in Smart Scrap has three top-notch expertise. We build supply chain from metallurgical waste material all over the world. So we sell alternative raw materials from steel mills and cement for steel mills and cement producers. The second one, we help electric arc furnace steel mills to reduce electricity consumption through fine-tuning of electrotechnical profiles. And the third one, we build waste management for steel mills like slag processing and establish sales channels. And now I would like to give the floor to Vladimir. Vladimir, hello.
Hi, Andrei. Thank you very much. Thanks for having me today. Thanks for the Smart Scrap team for organizing this webinar. I'm glad to be here. As you just mentioned, summer has been ended. We are in an autumn time. I hope everybody had a really great summertime, but now we're back on track. And I'm really excited to be here to present you some ideas and some use cases and the practical applications of AI and computer vision in the steel making. And with this, let me share my screen. I'd like to present you several slides which I prepared for this session. I hope you can see my screen. Andrei, please confirm. Give me a second.
Yes.
Now it works. Okay.
Mm-hmm.
So as Andrei mentioned, Warden Machinery is the company with the expertise in steel and mining. My personal expertise, my first education is actually in machines and steel making production, but it was quite some years ago. Beyond this, I work in multiple digital projects. I was part for Bosch system for many years. So different expertise and different domains in digitalization. But coming to our topic today, and let me share this slide. I'm pretty sure you saw this picture in the past. I'm pretty sure you know this because it's actually quite typical case when somebody is offering some new solution. In this case, guys is offering wheels, the round wheels for guys who is pushing the cart with the square wheels. Yeah, we see that people are usually kind of rejecting, and it's not only about steel plants, it's everywhere. I mean, I can also tell it by myself. I know that I'm using AI quite actively, but I still see the space where I can use it more actively to simplify my job. But then I tell myself, okay, no, I'm too busy. I need to do things in the old way. So that's about bringing innovation in our life. But before going into the more details, let me calibrate and understand the level of awareness, your level of awareness of AI. So I'd like to ask you to put in the chat one, if you are well aware, if you are using AI on a regular basis in a professional life or in your personal life. Put two, please, if you somehow aware, you know about this, you read about this, you try it, but not using it regularly. And put three if you have no idea what we are talking about. So you know that AI is a new buzzword and you have no idea how it works and how it might be applied. So this will help me to calibrate my presentation a little bit, going somewhere maybe deeper or maybe somewhere only scratching the surface, talking about technological aspects. And I would ask you to do this in the chat and maybe give another 5-10 seconds. And then, Andrei, if you can see the chat, please let me know.
Yes, people are coming. Yes, I see that one. I answered one, the first.
Okay.
So I see that all people well aware about using artificial intelligence. Yeah, we
Okay.
have a very experienced audience today, Vladimir. You can use.
I'm scary. I'm scary. If there are guys super experienced, maybe your expertise going beyond my one. And yeah, please keep your tricky questions till the end of the presentation. I hope I will be able to answer them.
We
But
have a
okay,
couple of
thanks.
questions, number two. But okay, so we can start.
Yeah.
So we have.
Okay, I think we have experts and maybe people who have a good ideas about what is AI. But just to maybe to calibrate, there are different flavors of AI, and I would like just to set the stage and align what we are going to talk about today. So everybody probably knows about large language models, these AI huge models trained on a huge amount of data that can generate texts and pictures and videos. And it's examples like ChatGPT, DeepSeek, Claude, Midjourney, and others. But today we specifically talk about different flavors of AI. We will speak about machine learning and deep learning. That's the fundamental things we are using in our technologies. Technically, we are also able to use large language models, and sometimes we're using in the chatbots, but it's quite heavy models, and they require a lot of computational power. So that not always makes sense to use them. So in a few words, difference between machine learning and deep learning is in the way how the model fit with the data. In case of machine learning, people give the explanation to the ML machine learning model about the characteristic of the object. Let's say if you are talking about the cat, the operator explains to the model what the typical features of the cat. It's mustache, the ears, and then the tail. When we are talking about the deep learning, you feed with a lot of the data. You feed the model with a lot of the data, and model understands different patterns by itself. That's a fundamental difference. And today we specifically focus on the computer vision. It's one of the subdiscipline in deep learning and machine learning. Computer vision is actually the technology which allows machine to see, classify, interpret, and understand images and videos. And in a practical way, it looks like this. You train your models on the amount of data, then you give the input to the model, and model doing the processing of the data, and as an outcome, model can tell you that's the cat. Again, that's the cat, and that's not the cat. That's actually the idea of doing classification of the different pictures and different videos. By the way, this cat on the left side, it's my cat, so that was not a big deal to agree with her to use her picture. Yeah, the situation with cat is easy. Why? Because there are billions of pictures available publicly in the internet. So, and actually beyond the pictures, there are already many neural networks pre-trained with the data and pictures of cats, dogs, tracks, bicycles, guns, or knives. That's the typical use cases for the security applications relevant for the Northern America. You know, the gun detection is a big thing for them. But when we are coming to the very specific data sets, when we are coming to the very specific applications, talking about industrial things, we have very limited amount of data. That's the first problem. And second problem, the data very diverse. So each and every time project looks slightly different or completely different. Even talking about the animals, I recall one of the project in my previous life we did in Australia, when the task of this computer vision was to detect amount of kangaroos and koalas crossing the highway. So they need to understand, that was a task to understand how much kangaroos and how much koalas crossing that way and that way to do some calculation for the national park. it's an animal, but it's different kind of animal than cat. And already in this case, it was an issue to find the right amount of data to train model properly. Talking about the industrial application, it's really not easy. So here I would like to show you a short video giving the examples of computer vision applications in industrial space. First video showing the coarse crush monitoring on the conveyor belt. Here we see the fragmentation analysis on the sintering process. That's the same process with the for pelletization, understanding the ratio of small pellets against the bigger ones. Hot rolling processing, the blue boxes, boundary boxes shows the defects on the hot rolled billet. Control of the positioning of hot cold rolls on the conveyor belt, floating process tuning, and this is a safety use case, detecting men in a hazard zone. And that one, the job card control, will speak about this a bit later, because I believe it's very interesting use case. It can go beyond the standard applications in a steel or any other industries. So in a few words about the world of machinery, as Andrei mentioned at the very beginning, we have more than 8 years of experience in steel, mining, and some other industries. We realized multiple projects in different countries, and we believe that we have a quite unique combination of expertise. So we were able to couple AI and machine learning with the steel and mining knowledge, which is, from my standpoint, completely two different worlds. But I believe that AI will be everywhere, and it's a kind of our mission to bring this technology into the industries, which is probably slightly slower adapting the new technologies in their operations. The company is based in Luxembourg, and as Andrei mentioned, we got a number of nominations in various industrial innovation challenges and startup competitions. So names like Sandvik, Bosch, or NL probably can tell you a little bit our background. And here on the right side, you can see some pictures from the ceremonies or from the real sites. Just to summarize why it's important to talk about computer vision. And it's not a secret that a normal person can stay focused on the routine operation, observing routine operation around 30 minutes. We know that the case in the security check at the airport, people are looking into the screen for the scanner, and they're usually changing each other every, I don't know, 2 hours in average. But they're well-trained people. We need to keep this in mind. And they keep their focus on one operation at a time. They sit back in this on the screen. They can analyze it. They're very focused on one operation. Talking about the steel mill, that might be multiple operations, multiple signals, multiple data, which should be analyzed by plant manager or by the technologists. So that's the reason why it makes sense to use the camera. Camera never sleeps. Camera work 24/7, 365 days a year. And if we are combining normal optical camera with thermal camera, we can achieve the result which is not possible to achieve by human eye. Using this approach, we can spot the bottlenecks, optimize different aspects of the production, bring down carbon emission, and actually also help to protect people and assets. And the statement which you can see on the bottom here might sound a bit arrogant or maybe too brutal, but really no hypes, no empty promises. We know what's possible and we know what is not possible. There is so-called CSI effect. We use this term during my Bosch time when I work in the video analytics division, that people expect that, like in Independence Day with Will Smith, you can see the guy on the Madison Square from the satellite and you can track him across the country. There is a different flavor of AI. I would say if the expectation of the customers of AI, it's kind of Ferrari. In reality, it's, let's say, Ford Focus or maybe Ford Mondeo. In the past, it was a bicycle. So the expectation was to have a Ferrari, but we would be able to deliver the bicycle. There was a lot of advancement over the last years in AI, so we can confidently say that we can deliver quite a robust solution. So we are open to discuss with the customer the expectation, and we openly say, okay, guys, that's possible, that's not possible, that's probably AI or computer vision is not the right tool to address your job. And with this, I would like to go to the explaining the value chain. Actually, we aiming to deliver the efficiency improvement across the whole value chain, starting from the underground mining or the open pit mining, down to the ore transportation, processing, and to the very final product quality check, and also optimizing logistic of your products on the warehouse. And here I would like just to give you a few examples of the use cases. For example, talking about underground mining, we can control the water flooding that might bring a lot of problems for the miners. Moving to the ore tracks or delivery, we can optimize the track usage process. So avoiding the underloaded trucks, and you can imagine that the cost of the fuel for these trucks is quite significant. So optimizing the track load can help to save a lot of money. And going down to the value chain, working on the optimization of the conveyor belt, control the conveyor belt, working on the granulometry analytics on the sintering stage or on the pelletization process. Working with the ladle logistic, let's say, to find the optimal way of moving the ladle across the plant and preventing reheating the ladle with the steel. Slag monitoring, we will speak about this in a little bit more detail later. Cast length calculation, surface defects detection on the hot rolling stage, and then the finally quality or geometry check, depends on your tasks. Moving on with the, give me a second, yeah. But actually, beyond the standard use cases which we deliver to our customers in steel and mining facilities, we're asked by the same company or the group of the company to deliver them some other use cases. And that actually generates additional kind of branch in our team, in our company, focusing on some other use cases like preventive maintenance, detecting the emergency cases like leakage detection or fire alarm, smoke alarm. You can imagine you cannot use the traditional fire alarm detector which you use in a commercial building in the industrial facilities. That might be different requirements, different devices. If you're working with the big diameter tubes, the welding assurance, quality assurance might be also the case for you. The case with the job card control I mentioned, and we will stop on this a bit early because I believe that's the use case with the high potential for many applications. We also have some experiments with the AR and VR, augmented reality, virtual reality, and providing the online support to the maintenance team during the maintenance process. And typically we say, okay, guys, if you have an idea what kind of data is missed, what kind of data will help you to take the right decisions, we're open to discuss this. We can use cameras or we can use any other sensors to collect the data, annotate the data, and analyze them and give you the foundation for data-driven decision. So the architecture of solution looks quite simple. It's simple on the picture, but in reality, you can imagine it's harsh environment. There are multiple special requirements for the equipment, so should be taken into account. But in this picture, it looks simple. You have a process, you have a sensor like camera or any other types of sensor. You stream the data to the edge server, where we usually use GPU, graphical processing unit, and run our software on this. And as an outcome, we send the data to the operator. It might be data in form of the metadata, which will be later integrated into the existing customer automation system, or we sometimes design, based on the customer requirements, design the charts and the user interface specifically for this application. That might, again, as I mentioned, data can be sent to the SCADA system on MAP system or can be visualized right away using our own interface. One of the things I think important to mention that we are providing the turnkey solutions. again, based on my experience in the different industries, usually customers take care about the final results. And if we start talking with the customers, okay, what is the camera resolution, the field of view, the dynamic range, what is the requirements for the memory, GPU, how many tops you need on the GPU, this all bring a lot of confusions on the customer side. So we are trying to keep these technical discussions aside and providing customer with the final results. Yes, obviously, we need to have a detailed discussion about the infrastructure, how we can deploy the system. The cabling might be requested from the customer side, some special things we can request, but in general, we are responsible for the whole solution, and the customer gets the data as outcome of the project. Are you still with me? The pace is okay, or should I stop on some slides? Any comments in the chat?
No, Vladimir, everything's okay. So,
Okay, I can move on
yes,
then.
we just have comments from Natalia. Your presentation is impressive. So,
Okay,
yeah.
thank you. Thank you. Okay, then I think we are good to go to the use case discussions. And I prepared a few use cases for you guys today, trying to make it a little bit, I mean, you don't never know the audience, so I try to make it simple from the one side, but still it's a little bit technical for guys. It might be technical for guys who is not closely related to the steel making, but it might sounds like super simple for the real metallurgists. So we have a process which is called casting of the metal in electric arc furnace. And during the process, we know like the slag is the form of the as a kind of byproduct during the casting process. And we know that slag contains the phosphorus and sulfurs, which makes steel fragile if the amount of slag will be beyond certain threshold. So the idea is to prevent going a lot of slag into the ladle. We know that slag, you need the slag. You need slag to prevent cooling of steel during the transportation of the ladle across the plant. But you need the decent amount of slag on your ladle. So keeping in mind very harsh environment, it's difficult to observe and notice how much slag went into the ladle. So we use the following solution. We install the camera, the thermal camera, which can detect slag in the stream. The camera connected to the edge server, which makes this analytics and calculation. And then we send the signal to the operator, which can take a decision. Okay, that's a lot of slag. I need to stop pouring. This solution helps to save 1.5, almost 1.5 million euro a year per electric furnace. And this saving comes to 2 points. This is reduction of the power consumption because you don't need to remelt steel which you put into the ladle with a lot of slag. And second, you reduce the deoxidizers, ferroalloys, and slag forming materials for the second casting of the same material. So the solution look like in reality like this. We have a very special camera in a special case, protected case. This camera is, as I mentioned, it's a thermal camera. This camera can detect slag in the stream of the steel because slag has a different temperature compared with the steel. And it calculates the area of the slag in the stream and understands the proportion and also can understand how much slag went into the ladle already. When they're coming to the threshold, which you define with your technologist on the plant, we can send the signal to the operator like this blinking red lamp and display this dashboard. Okay, you are coming to the threshold, you need to stop pouring. And it's much easier to look into the screen and to the lamp than to look into the pouring process. I mean, if you've been to the steel mill plant, I believe you can imagine that's not an easy to detect something during this process. That's the one use case. Another use case I'd like to talk today is on a bit early stage of the iron production. So here we're talking about the sintering process optimization. And you know that a sinter is a mix of iron ore, coke, and some other elements. You mix it, you crush it, you bake it, you crush it, and the final product is the sinter, which should be with a lot of pores. It should allow to gas to go through. If it will be not enough holes in the simple world, you will consume a lot of coke during the process. Will consume a lot of energy, because if the gas flow cannot come through easily, it will significantly reduce the performance of the blast furnace. So we define that small fraction, like below 5 millimeter, can close these holes and decrease the quality of the sinter, so decrease the efficiency of the blast furnace. We implement the solution installing several cameras, observing different stages. There are multiple things involved. We need also to measure moisture, the temperature, and so on and so forth. But this is the task for operator. We can observe amount of or ratio of the fine fraction coming as an end product. And if we see that amount of fine fraction more than 15%, for example, you define the threshold. But again, usually it's between 15 and 22%. If you see that it's going beyond the threshold, we send the information to the operator, and operator can change the mode. He can slow down the process, he can increase the temperature, change the recipe, and doing something online, on the fly. And this solution, based on one of the projects we realized with our customers, allows to save 2.5 million euro per one sintering machine a year. But beyond the saving on the cost, it was also preventing CO2 emission significantly and increase the performance of the blast furnace. So that's the sintering plant in real life, how it looks like. It's pretty impressive factory, pretty impressive foundry. And the calculation was done in the following way, how we reach these economic effects. I just would like to explain you in this slide. So normal, it was really big sintering plant. So the input in the sintering machine was 120 tons an hour. So it's pretty impressive. But as an outcome, you get 85 tons only, because the process built on the way, like you have 2 laboratory probes during the shift. And you can imagine that 2 probes during the shift is not enough. So you have a lot of low quality sinter, which you don't want to charge into your blast furnace. Creating this real time, you cannot call 2 times shift as a real time. So creating the real time connection, the real time loop, when we're observing what's going on as an end product in the sintering machine and sending operator the data. Okay, man, you need to change something on your process because you have too much small fractions, fine fractions. So we were able to reach 114 ton an hour performance. Believe me, even if it would be like 90, 91 ton, the customer would be absolutely happy, because each and every % of the improvement significantly reduced the costs. But this was actually beyond even our expectations. So that's really, really good achievement. And now moving to some other use cases. Not everybody is using the sinter or pellets as a charging material for the furnace. A lot of, especially Europe, a lot of steel mills are using the metal scrap. And there is also a problem. We understand that the scrap control using X-ray or radioisotopes, it's quite pricey from the one side. On the contrary side, the creative visual inspection by the operator might be not sustainable. So using the computer vision, we can prevent multiple issues, like detecting the potentially explosive materials, or detecting wood and tires in the scrap. And that gives you a few things. First of all, you're preventing going these unwishable objects into the furnace. And second, it gives you the arguments to speak with your supplier of scrap about the quality. So you might say, okay, your batch delivered last time was like 10% of the not metal components. We need to rediscuss the price for the scrap. So that gives you a little bit of space to negotiate with the suppliers as well. Another use case we briefly touch on the very beginning of the presentations. It's a surface defects detection on the hot rolled rails. And the idea is following: the earlier you detect the failures, the earlier you detect the defects, the cheaper will it be for you to rework them. Because first of all, the defects, the types of defects can give you an idea what's the problem. Maybe you need to change the speed of the rolling process. Maybe you need to change something on the temperature modes or on the recipes. Because if you detect these shells and cracks only on the final stage when it's already on the stock, it means that you did a lot of operation like for nothing. And the worst case would be if your customer will receive the products and say, okay, guys, with these scratches on the surface, we cannot send the product into downstream processing because that's not acceptable for our process. So that's the idea, to detect, and actually we can go beyond and classify. And it might work not only on the square billets or round billets, it might work on the complex geometry as well. It's a bit more complicated solution than installation of the cameras, but still it's possible to detect these defects on a bit more complex geometry of the final products. So that's just video from the camera. The blue boxes, blue bounding boxes you see on the screen, it means that the computer vision algorithm detected some scratches. Here on this video, you see only detection, but we also can do classification. And actually, it works like this. We define with you the classes, the classification of different shells or scratches. We define what is acceptable and what is not. And all this information will be logged into your system. So you can decide, okay, this billet is good enough. We can send it to the downstream. Or this billet is really need to be reworked and scrapped. That's the example of the defects categories. For example, longitudinal cracks and scaling, scratches, or shells. And here is the example of the exterior defects on the tubes. So you see the shells, you see the cracks. These cracks, it's easily to detect with the human eye, but these cracks appear when it's cooled down. When it's hot, human eye cannot see this in most cases. So that's the idea. Actually, sometimes we are offering to use the quality assurance in 2 stages, on the hot rolling stage and when it's cooled down, because different temperature of the material allows us to detect different problems. Everything is fine. I'm with the speed. We are going on the right way, or okay, sounds good. Then I will move on. Another use case, maybe not applicable for the guys who is using the electric arc furnace, but for the blast furnace, it might be a real headache. So controlling of the door seals on the coking batteries. Because if it's a problem with the sealing, the coke gas might be released in the atmosphere and it's quite toxic. So it might significantly affect the environmental aspects on your working place and lead to the safety issues. Observing this, using the camera, noticing the leakage on the early stage, we can prevent this and also can judge, okay, what is the problem? What is the tiers of the sealing on different doors? And also it can be kind of assessment, okay, maybe the problem was not with the seal itself, maybe it was the problem with the mounting of the seal. So that gives you a number of data points to analyze and to move on with your decisions. And the next use case is quite difficult, quite scientific, but I like it because actually thermal threatening is one of the very complex procedure. I recall it from my students' time. It was special domain. It was a lot of formulas, a lot of calculation we did in the university, like modeling this. But it's very, very interesting because the way of cooling down the materials significantly influence on the crystal lattice structure. And we know that crystal lattice structure is critical for the characteristic of the material, characteristic of your steel product. The problem is that we can measure temperature on the surface. We can use thermal cameras like this to understand the temperature of the surface. Unfortunately, there is no this thermometer which you can put into the rail onto the billet, like you can put into the beef steak and say, okay, I would like to have the medium rare, or I prefer well done. So no ways to put your thermometer inside of the rail. So that's the problem we are facing. So that's the challenge. What we can do, understanding the geometry of the rail, understanding the surface temperature, we can model the temperature inside. And it's quite complicated. I hope you will not ask questions about this use case because I need our data scientist to explain you in a bit more details. But on a high level, the distribution of the temperature is different in the different parts of the complex geometry product. If it would be square billets, it's easy to predict, but still not. So the distribution on the surface can be explained on one formula, distribution inside explained by the, if I'm not mistaken, Fourier equal. It's pretty complicated if you're talking even about the square things, but talking about the geometry like rails, it's really difficult. And based on this diagram, you see that depending on the deepness, you see the different curves, the way how the metal is cooling down. And moving on in a even more complex picture, just to give you an idea. So based on the mathematical model, we can understand that there are a number of layers and the interconnection thermodynamics happens between the layers. So the idea is to split this plane into the multiple zones and find interconnection between neighbor zones and understand the thermodynamics between these zones. This allows to more accurately predict the heat distribution inside of the rail or inside of your steel product. This is very critical because it helps to save you, first of all, energy and achieve the given characteristic, the given crystal lattice structure of your product. It might be problem if you're using the water to cool down. It might be problems oxidizing of the surface. So this use case is a little bit scientific, but I believe it's highly promising for the thermal threatening applications. And let me give you one example from, not from this probably steel, but I believe it might be relevant for steel makers and some other applications as well. Here we are talking about the so-called drop car control. In a simple word, we can teach computer vision algorithm about your maintenance guidance. Let's say you have a checklist, what people on your facility should do during the maintenance process. And there are a number of procedures. And we can teach computer vision to understand these procedures and control and log the accuracy of following the procedures. So actually, we are going through the checklist and say, okay, these guys, I can show you the short video on this. On the left side, you see the observation, and on the right side, the annotation of the operation. So let's say you have 18 operations in your checklist, and algorithm follows the operation and log that person doesn't miss any vital, any critical operation. So the guy is doing something on the gate valves, then he needs to loosen the valve for 1/4 of turn. And that's the way we treat and teach the algorithm to understand. And you see that algorithm can understand there is a tool, there is some elements, there is a bucket. So with this, you can address multiple problems. First of all, algorithm over the time can learn about the average time of the maintenance procedure or any procedure. Let's say you're doing casting, you can understand the average time of this stage of the casting procedure. If people, especially talking about the remote site, this is the case for the remote site in oil and gas plant. If you see that people accomplished this procedure far faster or far too slow, at least it gives you an indication that something was wrong. And you can approach person and ask, okay, John, what was wrong? Why you spent so long time there? Maybe it was a problem with the tool. Maybe it was a problem with the armature or whatever. So at least it gives you an idea. It gives you a data point to investigate what was wrong. And without this, looking just on the screen, it's just simply not possible to understand what was wrong and what was right. So everything is locked in, everything is estimated, and it gives you a lot of ideas how to move on, how to improve. And I believe that's more or less it about the use cases. Just a few words about the approach, how it works. It's not out of the shelf product. So it's not like you download the application, the computer vision. It's not that discipline that you download an application for your smartphone, like a sport app or whatever. it always requires a tailoring. As I mentioned, there is a limited number of data available to train the model, and each and every time, depending on the angle of the camera. So because you don't have a chance to install camera with the same field of view in a different factories, you need to have dedicated field of view. You have a dedicated processes, lighting conditions. There are multiple things which should be taken into account. So as a first step, usually we speak with our customers about their goals and targets with the project, digital project. Then we are installing the equipment and running POC, collecting the data, acquiring the data, retraining the model on the new data, and together with customers adjusting the process. Then we show the results. If everything works well, we can move on to the commercial scaling, and then we can speak about the integration into the SCADA system, into the private cloud or whatever, and maybe going into the more details and retrain the model for very specific applications. That's the scope of work we are doing usually with our customers. That's more or less it from my side. I'd like to say the big thank you for your time. I hope you were passionate enough to listen to me. It was sometimes maybe too complicated, sometimes maybe too on the surface, but I hope it was useful. And yeah, if you have any questions, if you have any ideas for your facilities, we're happy to talk and deep dive into your particular use case. Thank you. Any questions? Yeah.
Yes, thanks, Vladimir. It's a very impressive presentation, and I would like to ask the audience to rank this presentation. I will mark like a 10. At least it is the best. So it's very impressive and a lot of useful cases. My question, Vladimir, and the audience, I would like you to also to join us for a question and answer session. And my question is about during one of our furnace optimization project, while our engineer were on site, incident occurred. The electrical furnace lining failed and production had been stopped. The investigation showed that the main reason, the first, a change in the original slag door pillar design that created weak joints in the refractory. And the factor led to a hot spot, a shell puncture, and eventually the shutdown of the furnace. And my question is, how could computer vision help in such cases? Could early detection of abnormal lining condition or thermal stress have prevented this failure?
I believe yes. You know that the devil is always in detail, but I believe it might be several stages what can be done in case of applying data scientific approach. First of all, we can observe, as I mentioned, the job card control. We can observe that the operation with the preparation of the furnace for the casting was done in a proper way. That's the first step I see as a potential outcome. Second step is really to have the visual inspection using the cameras or maybe thermal cameras to understand the solidity of the wall. And based on this, we can take a decision, okay, if it's good enough for casting or we need to postpone it or redoing something. So my answer, yes. And I would propose to actually approach it from, as I mentioned, two stages: the quality control of the maintenance procedures and the control of the surface of the wall as a final product.
Okay, thank you. And the second question from my side, as I know, large companies like Primetals, SMS, and Danelia are already working on computer vision solutions. And what do you think, Vladimir, how is Warden Machinery can compete with such giants?
Yeah, very relevant question. As you mentioned, Andrei, they are really giants and they're focused on building steel mills. And yes, obviously they have the computer vision competence and they have their divisions working in the computer vision. But let's be honest, their core business is building steel mills. And computer vision is just side product, which they deliver to their customers as a part of the complete solution. For us, computer vision is home domain, home turf. So we know this very well. We are focused only on this. We are much more flexible. We are eager to start with the light POC and the negotiation. I mean, mostly we face with the situation that customers, it takes for the customer a long time to agree with us, but we are quite flexible and easygoing. In case of big players, I mean, once again, big in the enterprise in the past, I can say that the process is very slow. And the industry itself is very slow. So giving a little bit of dynamics, bringing startups, I'm not only talking about Word and machinery, but any startups who is agile, who is quickly try, quickly fail, but try again during the pilot stage. That's the reason for the pilot stage. We are trying to deliver the real impact to the customer and showing, okay, that's what we are aiming to get. If you will agree on the contract for 2 years, I mean, yeah, it might make sense in some cases, but I think we need to move fast nowadays.
We have question. Do you combine LLM plus computer vision for some cases, or only computer vision models are used in your use cases? This question from Emre Tadbark.
We used LLM predominantly for running these assistants for the maintenance team in the form of the chatbots. Using VLM, so-called video language model for visual detection. It's a heavy lifting thing, so it requires first of all, a lot of computational power, which once again, I'm pretty sure one day we will come to the point that we will use VLMs because it has a lot of potential, but it's from our standpoint, it's a little bit raw and it's very heavy in terms of the computational requirements. So in most cases, the traditional ML model is good enough.
Thanks.
I hope you answered the question.
Yes. Vladimir, my next question is for you as a head of business growth of the Gordon. So when you are going to speak with people in steel mill, and we spoke with you that steel mill industry is very conservative. So when you start speaking about artificial intelligence, etc., so what do you feel like it's if you speak about artificial intelligence, it helps you in negotiations or not?
You know, it's I have a feeling that people feel themselves like staying with the parachute in the plane. It's very exciting to jump, but it's also very scary because obviously we can prove that it brings a lot of benefits, and that's the reason to run once again the pilots. So we are not asking to pay millions and so on. We can show the results, and based on the calculation I just demonstrated, like the return of investment in 2-3 months. It's just impossible to imagine any of the big companies you named can build the factory with the return of investment in 2-3 months. That's just no way. It's tens of years sometimes. So you see the spark in their eyes. They're very excited about this, but they're also scared because, and I do understand why, because their process built in a different way. They are not fit to these innovations. So this, in a very lucky case, there is a digital teams who can guide and help in changing the process. Actually, sometimes the beauty of the computer vision, you don't need to change the process. You have your process in place. In any case, you change the process if you see the faulty products as a result of your operation. The problem is that you see these faulty products too late. The idea with computer vision to give you signs and ideas, to detect it in early stage. So if I don't know if you answered the question, but as I said, I see the fire in their eyes, but also a lot of scare to how we can approach this. And that's our task to guide in the right way.
Yes. When I spoke with one person, we discussed about this technical sales and to provide the efficiency through technical solutions. It is not about technical, it's psychological issues. Yes, as you told, like
it's a first place. It's not only about changing the process on the technological side, but understanding and mindset. That's the challenge, the most challenging.
We have another question from Ahmed Shafiq. For hypoatonic steel, is it possible to analyze the A3 critical temperature through artificial intelligence implementation to pass it out towards level 2.3 automation before hot rolling? It's a very specific question. To be honest, I don't understand it, but
I believe I will answer also in a generic way. If you can grab the data which can be used for the modeling of the process, I believe it might be analyzed. I mean, the example with the rails and the temperature spread and distribution in the rail, it's a very good use case because using the computer vision, it's actually not even a computer vision. It's just the understanding of the temperature on the surface. But that's one of the data points we collect. And then we use really heavy mathematical model to understand, to make an assumption about the heat distribution inside. I also don't understand fully the question, but I believe that if you have enough data points, or these data points can be collected before the hot rolling, I believe we can give this to the algorithm and analyze this process.
Okay, good. So any question from the floor? No. Vladimir, can you close the presentation?
Yeah, give me a second. I stop sharing. Yeah.
Okay. So, colleagues, first of all, again, thanks to Vladimir about so impressive presentation. Now we understand more about the implementation of artificial intelligence in not only for office work, not only for marketing, yes, but also for industrial purposes. It's very impressive to me. And yes, and for the audience, I would like you, if you like this webinar, please rank the webinar, and also I would like to ask you to repost, and it will help us to grow. I find such interesting speakers like Vladimir, and we will continue Smart Scrap Talk. And to Vladimir, I wish you and the Arden technology to find your place in the market, and it's very impressive. It's very interesting things what we are doing, but I understand that it's not easy to.
We usually call it heavy lifting in heavy industry. So that's definitely not easy. But when I saw the first calculation about ROI, I was absolutely impressed. I was blown out because, again, coming to this ROI in 2-3 months, you hardly can find the application where you can get to reach these results. And many spaces like we already use artificial intelligence in marketing, as you just said, in office applications, you can have some small incremental improvements. But here in the industrial applications, that's endless opportunities for all of us. And again, thank you very much, Andrei, for having me here. And for the audience, I just would like to propose, let's do this transformation together, because it's, as I said, it's heavy lifting, and only together we can do it for better for us, for the better quality of products and better quality of life, because it's significantly influence also on the ecology. The steel making, by the way, is accounting for the 7% of the CO2 emissions worldwide. So it's pretty hefty. So if we can make some small incremental improvements in terms of the emission decrease, that's also a good foundation for the future.
Good. Thank you.
Thank you. Yeah.
Okay. Have a good
Bye-bye.
evening.
You
Bye-bye.
too. Bye-bye.
Bye-bye. Bye-bye.